All right, here's the example. Same thing, let's look for its boundary points by setting it more or less equal to 0. When we do that, we find its boundary points. But when we do our test points, we're going to go back and test it within the inequality. So this one might take a little bit of work here. Subtract 2 from both sides. So I kind of have that going on. In order to add these together, I need to get a common denominator. So my common denominator is going to be an x plus a 3 over an x plus a 3. And that's still greater than or equal to 0, but at 0 is where its boundary points are at. Adding these together, my numerator is x plus 1 minus 2x minus 6, all over the common denominator of x plus 3. I think I can combine and collect some terms on the numerator. So the numerator is a negative x minus a 5 all over an x plus a 3. And that function is still greater than or equal to 0. So this helps us now. Now we're in a position to determine where its boundary points are at, or its boundary situations. So one boundary point is where the numerator equals 0. So negative x minus 5, where does that equal 0 at? So it's negative x equals a 5, x equals a negative 5. So that's one boundary point. The other boundary point in a rational expression is where the denominator crashes, hits to 0. So that's an x plus a 3 equals 0, or x equals negative 3. So from there, I have my boundary points. So if I were to graph on a number line, and I have 0 or negative 5 and negative 3, I'm just checking they're both negative. Yep. So let's put 0 over here then. Negative 1, negative 2, negative 3, negative 4, negative 5, negative 6. One boundary point that I'm going to check is 1, 2, 3. And 1's right there. So I have 3 sections to choose from. One section is from negative infinity to negative 5. Another one is from negative 5 to negative 3. And the other one's from negative 3 to positive infinity. I do know that it's also an equal to, so these are hard brackets in between, which I'll change here in a moment. So how do we find out it's true? Or which areas are true? Let's try a couple of test points. Let's try 0 to begin with. So that would be a 0 plus a 1 over 0 plus a 3. Is that greater than or equal to 2? So I get 1/3 greater than or equal to 2. Is that true? No, that's not true. So this is a no. Let's try a test point now in the second section, and let's try negative 4. So negative 4 plus 1 over negative 4 plus 3. Is that greater than or equal to 2? So I have a negative 3 over a negative 1. Negative 3 over negative 1 is a positive 3. Is 3 greater than or equal to 2? So the second section produces a yes. And this last section, let's choose a test point. Let's choose a test point of negative 6. It's representative of all the test points. So negative 6 plus 1 over negative 6 plus 3 greater than or equal to 2. Negative 6 plus 1 is a negative 5. Negative 6 plus a 3 is a negative 3. Is that greater than or equal to 2? Negative 5 over negative 5, that's a positive 5/3. That's just a little bit less than 2. So this section produces a no. So my solution set then includes, well, it looks like it only includes this middle section right here, and the boundary points are also included in that. So my solution then is simply the hard bracket of negative 5 to negative 3 in interval notation. those values make our original rational inequality true, or that's where these values make it positive, is one way to say it too.